Hey everyone, noticed that in class today there was a little bit of maybe unsureness or hesitancy regarding some the improper integrals that we did. So I wanted to take a look at one more, do a short little video of it. I pulled this from WebAssign, so my numbers might look a little bit different from yours, but only the 11 should be different. Determine whether the integral is convergent or divergent, and if it's convergent, then say what it converges to, right? In other words, evaluate the integral if it converges. And if not, then say it diverges, okay? So this one, I hope that you could look at this one and see, we've got a negative x squared in the exponent and an x in the base. So maybe a u sub is in the mix here. Now with u sub, it's often easiest to just ignore the bounds. So what we might want to do here is say, just treat this as an indefinite integral, and then when it comes time to plug stuff in, then treat it as an improper integral. So maybe we'll say, in general, the integral of 11x e to the negative x squared dx is going to equal, and I'll show this in a sec here, but it's going to equal 1/2 times 11, I guess it's going to be negative 1/2 times 11 e to the u du, right? And what we did here, I'll put it up here, u equals negative x squared, so du equals negative 2x dx, and so negative 1/2 du equals x dx, and that's what we've got here, right? Right, x dx equals negative 1/2 du, right? Okay, so we've got that. We do this out, we get negative 11/2 e to the u, and then we're going to get negative 11/2 e to the negative x squared. I'm not going to do plus c because remember, this is a definite integral, right? We're going to be plugging stuff in. Okay, now that's in general. Now we see that we've got plus and minus infinity, right, in the upper and lower bounds respectively. So we need to split this integral up. So I'm just going to write that. On a quiz or exam, you don't need to do this equals its two components. You can just integrate each of the two components. I don't know what you're talking about. Looks like we need to maybe drag it down a little bit there. Drag it a little bit further. All right, plus here. Okay. So what I'm going to do, though, is I'm going to use the fact that we integrated this in general so that for each of these parts, I'm just going to cut right to the chase of plugging in the value in question. Maybe I'll do this part in red and this part in green, should they both wind up converging. Okay. So I'll say this integral, and you know what, I'm just going to skip the step and talk about the limit as t approaches negative infinity. Integral from t to 0. Again, cutting right to the chase here. This is negative 11/2 e to the negative x squared from t to 0. And this is going to give us, right, e to the 0, that's fine. E to the 0 is 1, right? So it looks like we're getting negative 11/2 times 1 minus e to the negative t squared. And here you just need to use a bit of reasoning. What's e to the, so I guess t is approaching negative infinity. Negative, well, it doesn't matter. We're squaring it, but then we're making it negative. So this is the same, just to be clear, as negative 11 over 2 times 1 minus 1 over e to the t squared. Right? And e to the, now it doesn't matter whether the t is approaching negative or positive infinity, you square it so it gets big. E to the t squared gets big, which means 1 over e to the t squared is small. So this actually goes to 0. And we are left with negative 11 halves. Maybe I'll try to squeeze it in right here. Okay. Just so I have room for the next part, right? So now we're going to do the same thing, right? But except he is approaching, well, maybe I'll call it s or something, right? S is approaching positive infinity, and we're talking about the integral from 0 to s. If you use t, that's fine. You know, I don't have a problem with that. And again, cutting right to the chase here. We already know the integral. Don't waste any time actually integrating. And, right, oh, shoot. Sorry, in both cases, I committed a major faux pas here. I do apologize for that. Right, I ought to be writing the limit in every single time. Let's try to maybe resize this bad boy, really squeeze it in here. Right, equals the limit. Equals the limit. Right, please keep putting it in. Okay, keep putting it in. And we got to put it in here too. Paste it in there. Sorry about this interruption. Move her in here. There we go. All right, so now anyway, in here, right, we ought to be squeezing this limit in as well, right? Well, actually, I guess what we can do here is move this guy over here. Now, paste it in. Okay, maybe shrink it a little bit. Whew, okay. Okay, and now we're going to get that this equals the limit as s approaches infinity of negative 11 halves e to the negative s squared minus, here, minus e to the, well, negative 0 squared minus 1. And again, we have to think about what that means. Well, if you think about it, it's actually the same thing. So we're going to get that the answer is, again, this goes to 0. And we are left with negative 11 halves. Oh, wait, nope, sorry. Positive, right, because it's being multiplied by 1. Right? So it looks like our answer here is actually 0, doesn't it? That doesn't seem quite right. Is it really 0? Well, maybe it is, right? Maybe I'll do this in blue here. So the integral converges to negative 11 halves plus 11 halves equals 0. That is totally possible. This isn't just areas. You can have positive, negative area. So it looks like the answer is 0. Yeah, actually, that makes sense because the x right here is going to make it negative when you're on a negative interval and positive when you're on a positive interval. So there you go. The function should be symmetric. So actually, the answer of 0 makes perfect sense. So a little bit involved here, right? Sorry about the limit notation issue there, but a u sub problem. Again, with a u sub integral, might make sense just to integrate it generally, then do your improper plugging in.